Hello everyone, I'm Kishore John, URK24CS1064 from Cornell Institute of Technology and Sciences. This video is all about DSA Labs experiment number 4, array implementation of circular cube in Python. Come on, let's get into the video. Previously, we have discussed in detail about the array implementation of linear cube, and now we are going to discuss about circular cube. So previously, we have discussed that linear queue has a major disadvantage. That is, once the front and rear pointer have incremented till the last index, which means the okay, which means one cycle of filling the queue has been completed, and also the entire elements has been deleted. After that, the queue cannot be used. So here in circular queue, even if the entire queue till the seventh index has got filled, and for instance, the elements at the zeroth and first position are deleted, so we'll be having empty positions at 0 and 20. We'll be still able to store elements at 0 and 1 position with the help of rear pointer. So basically, the rear pointer on the front pointer is gonna revolve around from this last position to the zeroth position, and it keeps on incrementing. So as long as there is an empty space, you will be still able to fill the position with an element. So let's get into the Python implementation. So this is exactly the code which is gonna facilitate the disadvantage which linear queue has given us. Now let us see. So it has got, as usual, Q, NQ, DQ, display, and of course, set of functions or set of objects and callings, which of course is used to check how this implementation is going to work. So if you see NQ, here we have exactly specified in the conditional statement rear self.rear plus 1 percentage self.size. Exactly this is the condition which gives the rear pointer the ability to attain circular queue functionality. And again, if you see in the DQ, we have this uh, this special set of line which gives DQ the special functionality to attain circular queue functionality. And at last, as we have seen earlier in the implementation of linear queue, this is all going to be the same except this set of line and set of increment and decrement, which we'll be discussing in the video. Now, let's run the code. As you could see, first for the first three lines, we have inserted 10, 20, 30, and we have displayed, which has successfully displayed 10, 20, and 30. And now, again, we are enqueuing, that is, inserting 40 and 50 and 60, which is again, of course, along with the 10, 20, 30, and 40, 50, the remaining elements are also inserted. Now, we are removing, we are dequeuing once, which has removed 10. So as it is a queue, the first element, that is first position, is going to get removed, and we are displaying, and successfully it has remove the first element and display the queue accordingly. Now again, when you hit the display, you can see that after the enqueuing of 60, it is able to store the 60. If it is were a linear queue, you wouldn't be able to store any more elements as the threshold has reached, and even though there is an empty space at the first index, you will still not be able to store, which is different in circular queue. That's all about the video. Thank you.